All right, good morning. Welcome to the next class of 1351. So let's close this. This is, of course, the course website, which I encourage you all to study and understand completely. Here is the syllabus. Today is January 29th. We're still talking about arrays. However, on Friday, we'll start talking about basic graphics. Ooh. All right. We're going to have a quiz today, so yay. Maybe this time it'll work. All right. I just discarded the last one because some people took the wrong quiz. And so look, instead of giving you 100% for free, I'm gonna drop the lowest X tests depending on quizzes, depending on how many we get. All right. Okay, let's take a look at my list impl. So one of the things we talked about last time, if you remember, was how to remove an element from the end of a list. And was you, right? That gave the answer. What's your name again? Isaac. I knew it was an I. So what we have is a remove last. And what that's going to do is it's going to say logical size greater than 0, logical size minus minus, right? So that's going to actually do the job for us. Now, there is a slight problem, right? And that is if I go and call my get method on this array, it's still going to return, and I go past the end of the logical size of the array, it's still going to return that value. I could put an assert statement in the get method and the set method to prevent that kind of thing from happening. But right now, this is just user error. If a user fetches a value past the end of the array like that, that's on them. But we'll come back with better ways to handle that later in the course. Any questions? I feel like a game show host with this microphone. All right. Okay, so remove at index, right? So now we're going to do something different. We're going to, instead of removing the last thing, we're going to remove something that's not the last. I mean, it could be used to remove the last thing, but it doesn't necessarily have to be. So what this is going to do is it's going to do the same thing as before, decrement the logical size, because at the end of this, regardless of where I take that element from, there's one less in the array. The next thing I have to do, though, is I have to copy things down, right? I have to make sure that gets filled in. So this time, I'm not going to do a backwards array. I'm going to do a forwards array. So when I did an insert, I wanted to do a backwards array. Now, when I want to do a remove, I'm going to do a forwards array because I'm copying the other direction. Okay. And I don't want to overwrite the things that I'm doing. So what I'm going to do is I'm going to start at the index I want to delete. And I'm going to copy things. I'm going to copy the thing at n+1 into n. So that will destroy the value that I'm removing. And it will shift all the other values down by 1. Does that make sense? Yes. Name? Bo? I mean, I can do it either way, right? When I'm doing it this way, I'm taking into account the change in logical size that's going to happen in my loop, because I know that I need to reduce that. I mean, I could write it either way. You just have to make sure that you know what you're doing and that you test what you do. Testing is important. It's good to ask questions, because the more questions you ask, the less I can plow ahead and the less things I can give you that you have to learn. All right. So it's important for that reason. It's also important not to fall behind. You know the pirate code? Them that falls behind gets left behind, right? You know that's from the movies now. Didn't watch Pirates of the Caribbean? Well, anyway, that was the pirate code in those movies. You don't want to fall behind, because once you fall behind, it's very hard to get back caught up. Okay, so yes. So what I'm doing, right, is I want to copy. Let me try draw that a little text picture. Let's see if we can do that. So what I want to do is, if I have 1, 2, 3, 4, 5, 6 in my array, and I want to remove 3, then what I want to do is I want to have 1, 2, 4, 5, 6, right? So what I need to do is I need to copy. The 1 and the 2 can stay where they are, but the 4 and the 5 and the 6 have to be copied down, right? That's the logic of what's happening there. And we kind of do the reverse thing when we insert. Yeah, so insert, we have, well, what's right above there, I did a +1, but so you notice that the +1 is on the other, yeah, the bubble sheets are over here. The +1 is on the other side of the equal sign, right? And I'm going down instead of up. Yes.
So in this case, the and that's coming in would be 2. So it specifies starting at number 2, it copies over.
Yes. Yes. Okay. All right. So any questions about that? You know what? I'm gonna try to, just for the sake of clarity, I'm gonna move this. I'm gonna copy this up to here. And I'm going to do that just to sort of complete the picture. Does that make sense? Any other questions? You all understand it perfectly and could take a quiz on it. Yes. Yes, you do. Yes, you do. Or you have a question. Go ahead, ask your question. No? Yes.
So for the insert, in that for statement, why is it logical size -2 specifically?
So what we did, the way I was thinking about this was logical size -1 is the last valid value, right? And I've already and then I decremented logical size before I started. So that got me a 2. And you know, when you're fiddling with these 1s and 2s and things like this, it's easy to confuse yourself and get it wrong. And this is why it's important to test. Quiz bubble sheets right there. All right. Yes. Name again? Drew. Well, I'm only removing one thing. Oh, because yeah, so the logic is different. I'm not starting from the end, right? And I'm starting from the beginning. So when I start from the end, I have to put a -1 on there just to begin with, because that's the last valid value, right? And so I only need a -1 for the next one, but I did the minus first, so I didn't have to do it in a loop. And as I say, it's easy to get yourself confused about such things, and easy for you to just listen to somebody say, hey, this is what you should do. And your brain can say, oh, yeah, it makes sense. But nothing beats actually putting it into a computer and trying it, which is something I encourage you all to do every day. Yes.
What is it? Is that like the spot?
Int n is the index that's the one I'm removing. So in this case, it would be 2. All right, all makes sense. You understand inserting and removing and all that. Okay. And appending, let's not forget that. Appending is actually the most complicated thing because it involves growing. All right. Iterator. So the iterator is an alternative way to go through a list. It's sort of a generic thing. Arrays and lists and everything implement this, and even other things that you haven't heard about yet. And the way this works is there is a special method called iterator that returns an iterator. The iterator object, capital I, lives in the package Java util. Now, if you look at the top of my class, I have imported java.util.iterator, and I implemented iterable. Now, iterable lives in java.lang, so I don't have to do an import for that. But iterator itself lives in Java util. Okay, and what iterator is going to have on it is going to have two methods. And you know, I'm actually, oh, I see what happened. I made a mistake here. Okay. And I should probably cast that. Okay, so iterator has two methods on it. It's got Boolean has next, which asks whether there's another thing to iterate over, and there's object next, which gets the next object and advances, so you know, to the one after that. So if you call next twice, it should get two different things. And the way I'm going to make this work, well, before I show you how it works, let's go ahead to the bottom of this thing and look at how it's used. Now there's this magic enhanced for loop thing that you've seen before, right? And the magic enhanced for loop actually can work on anything that implements iterable. So if you make your own class that implements iterable, you can use it in your magic for loops. Okay. Now, in this case, right, what I want to do is I just want to go over the elements of the list. I'm going to just print out the integer and then a space, right? This is just, you know, it's going to have an extra space at the end, but that's fine. And I'm going to print a new line. So that's what it does. It makes the enhanced for loop work. Okay. So how do I, well, let's actually, now that I think about it, I want to show you the non-enhanced for loop. So with this code, what this code does in this for loop here is going to expand into the following code. Okay, it's going to expand into this following code. What it's going to do when it sees the enhanced for loop is it's going to get an iterator from that object. Then it's going to turn that for loop into a while loop. And it's going to say while iter.has next. And then it's going to get the next object from that iterator by calling the next method. Okay, so whenever Java sees that first thing with the enhanced for loop, it's going to generate that second thing silently without, you know, just magically for you. Make sense? Anybody have a question about that? Yes.
How does it specify the iterator? I see where the -2, but how does it know which part of
So what happens is, right, the thing that I put in the enhanced for loop has to implement class interface iterable, right? Java.lang.iterable. And iterable has a single method on it.
the top line up there?
Yes. So that's all it needs to know to generate that code. Yes.
So what would iterator be used for?
It's used for this. It's used for going through a list or an array. The point is it's generic, right? If I have a list or an array list or this list that I made up myself, I can use that same enhanced for loop to go through it, right? I have more generic code. And more generic code means if I later on decide I want to change the way something works, it's easier to do. So the idea behind any programming is to tame complexity. And the way you tame complexity is you want to break things down into individual pieces, which you can analyze separately. And if you want to change and you want to have interchangeable parts so that you can move things in and out if you need to without breaking everything, right? So those are the things you're shooting for. And that's why it's nice to have something like this enhanced for loop, which can work with any kind of container, right? Whether it's one of the built-in ones or one I made myself, anything. Okay. So that's why I want to do that. Anybody have another question? This is going so much faster than I thought it would go. Yes.
So in the expanded part of the enhanced for loop, is the casting of the integer for iter.next, is that just n in the enhanced for loop?
So that's the n in the enhanced for loop, right? And var is just going to be, the compiler is going to fill in a type for me. It's going to figure out what goes there. Now, I don't know that I have to put the cast there. I think Java might be smart enough to figure out what I want, but I thought it might be nicer to make it clear, because the next method is going to return something of java.lang.object, right? And java.lang.object is not something I can print with %d. And neither is a capital integer, to be honest, but I think it's clear that Java automatically converts capital integer to int and vice versa as it needs to, right? Yes, Drew. %d is a format specification. So last time I taught this course, right, and I put these format specifications up like this, I said, how many people have seen them? And everybody raised their hand. So I'm just going to ask that again. How many people have seen those %d things? But okay, all right, good. I feel better now. And there's just a few of you who haven't seen it or don't remember it. But okay, yes, Serene. %d means integer. So what it's saying is I want that string to have an integer followed by a space, and then the next thing in the argument list is the integer that goes in for the %d. Yes. The compiler I think the compiler will tell you if you got it wrong. It might be the runtime. I can't recall. But the nice thing about format specifiers like that is they can do all kinds of things for you. So if you want to specify a floating point number and you only want 2 decimal places to show up, you can say %.2f, and that's how that works. But we'll get into all that in more detail later. Right now, just %d as integer is fine. Next question. Yes, Drew. Okay, so it's always a valid thing to ask me to re-explain something or to explain it slower, because sometimes it takes just a little bit to get into your brains. So when I did the expanded version of the enhanced for loop, what the compiler generates, right? What it's going to do when it sees that thing is it's going to take the thing on the right-hand side of the colon in the loop, and it's going to make sure that that thing is iterable, and it's going to then fetch an iterator object from that iterable. The iterator object is going to know how to step through your container, your list, your array, whatever, one step at a time. All right. So first it has a method that has next that asks, are there more things in there for me to look at? And then there's the next method, which fetches the next thing and advances so that iterator has next can try again. Okay. So next is only going to fetch a value once, and then it's going to move on to the next value. Got it? All right. So let's go back up to the implementation of iterator. Okay, the implementation of iterator is, what is that? What is that code that I have there beginning on line 118? It's a return. What am I returning? An iterator object. What else might you call that object? An anonymous inner class, an anonymous inner class, right? So the syntax for an anonymous inner class is, I've been trying to point out, it starts with operator new. It then has the name of a class or interface. It then has parentheses because there is a possibility of constructor arguments being passed to this thing. Then there is an open curly brace, and everything from that open curly brace to the closed curly brace is the implementation of a class, right? So what I'm doing is I'm describing how a class works and instantiating it all in one go without giving it a name. So it's some subclass of iterator. All right, but it doesn't have a name. Make sense? Now, yes, Drew. Yes, I'm making a small class inside of a big class. Well, I'm not sure. How would you call it outside? Well, okay, so this object doesn't have a name, right? So I can't really instantiate it anywhere else because I wouldn't know. There wouldn't be a way for me to tell the compiler how to do that. Yeah, it only exists in this one place, right? And the only time you want to do this is if the class that you're creating is small and simple enough that you want it all to fit on one screen. Now, in this case, I'm putting, what do we call int n there? What do we call that? It is an instance field. Yes, it is an instance field. Okay, it is an instance field for this anonymous inner class that we've created. By the way, iterator, right? That's an interface. Remember that. So I can't instantiate an interface directly, but I can subclass it and instantiate it like I'm doing here. Okay, so iterator has two methods on it. It's got Boolean has next and it's got object next. So Boolean has next, what I'm going to do is I'm going to say if n is less than logical size. So I'm thinking that I want to ask, is there a value at n? And n is going to start at 0. So if the illogical size of the array is greater than 0, then that first has next is going to return true. And if the array is of size 0, well, then it's immediately going to return false. Okay, so we can see that part works, right? All right, so then what I'm going to do is when I go to fetch the object from the array, I don't think I need to do the cast integer. I think Java will figure that out, but I think it kind of helps you see what's going on. What I'm going to do is I'm going to fetch the data at index n, and then I'm going to advance the value of n, right? Because you remember this is a postfix ++ operator. So between these two things, I have an implementation of the iterator. Okay, let's take okay, questions. Yes. What was your name again? Vanek, okay. Yeah, anonymous inner class is a difficult concept for many students at this level. So an anonymous inner class has the following syntactic elements, right? They're always there. There's operator new. there is a class or interface that you are subclassing. There are parentheses, which contain arguments, if there are any, to pass to the constructor of that class. If it's empty like this, that just means it's a default constructor. And then there is an open curly brace. And then everything from that open curly brace to the matching closed curly brace is going to be the body of the class. And anything that you can put inside a class, you can put here. You can put method field declarations, you can put method declarations, you can put static fields, you can put static methods. Anything you could put in the class definition, you could also put here. Does that make sense? Logan. Yes, I need the semicolon at the end. And the reason I need the semicolon at the end is that everything from the beginning of keyword new to that close curly bracket is a value. It's like the number 3. So I'm kind of like saying, it's kind of like if I said return 3, I'd have to put a semicolon after that. I have to put a semicolon after this too, because that whole big thing, as long and complicated as it looks, is just a value at the end of the day. What's your name again? JJ.
So I did say that, like, for almost in our class, it's something that you're going to want to put for class, right?
Yes.
Like, what specific reason?
Well, let's take a look at what we would have to do if we didn't want to use the anonymous inner class. Let's re-implement this. So I think that will work. Let's try it out. Method does not override. Method has next is already defined in my iterator. Oh, I call them both has next. What kind of a brain glitch is that? All right. Okay. So at the bottom, the last 2 lines, you're seeing the results of either the enhanced for loop or the iterator while loop. Okay. And you can see that they work this way. Let's go back and look at what I did. All right. So what I did, right, is I had to, instead of using an anonymous inner class, I had to construct all that code up there. And then I had to invoke it down there and pass the this in. So when I create the anonymous inner class, I capture, remember we talked about capturing, I capture the fields and information from the enclosing class, right? So I automatically know about data and logical size, and I don't have to have a special field to reference it. But if I want to use something different than the anonymous inner class, then I have to explicitly pass a reference to my list impl in, and then I have to save it, and then I have to use it. And I have to go from one of these things to the other to see what I've done. So you can see that using the anonymous inner class is a little less clunky, right? And when you look at the code, it's a little more straightforward. Does that all make sense? All right, let's take a quiz.